Hi, this is Ray Liang doing the probability and stochastic EL6303 HW10. This time the first question asks us to define and collect the properties of the following stochastic processes, that is in Poisson process and Poisson increment and normal process. So first things first, about the Poisson process, the definition is given um, a constant t0, which in this case is not a constant because that time I grabbed this definition from earlier the book. That is not the um, stochastic process. Uh, Define a random variable n such that the values of n is a number of points in the interval that happens in 0 to t. And the properties it may have the and from t to t and from t1 to t2 of points that is represent the number of points happens in the interval from t1 to t2. The length is equals to tau. The Poisson random variable with a parameter lambda tau, and the probability mass function could be written as n in the interval of t1 to t2 equals to k is equals to e to the minus of e to the power of minus lambda t times lambda t power of k over the k factorial. And the property 2 is that if the two intervals, that is t1 or t2 and t3, t4, are non-overlapping, the random variables of n1 and n2 are independent. The PMF functions here, and the expected value is only defined by the parameter of a Poisson process, and the correlation, the other correlation is represented here, which could be depends on the starting time, because we have the minimum of t1 and t2, and thus lead us to the expected value is not a constant in the all correlations matters with some starting time, so it's not a white sense stationary process, but it follows the Markov properties. In order to have a process that has some similar properties like a Poisson process and represent that numbers of point happens in the interval 0 to t, and also have the white sense stationary, also the maybe the strict sense stationary property, we kind of like introduce the Poisson increment, which is here define the yt as new random variables that is defined by the xt plus tau minus t xt over the constant c, and c is a fixed number here. It's like a little incrementality to the time, and do the differentiate, and then like a Poisson increment. This time we could write a probability as this probability mass function y equals to the n over c, which is an x here is x in the interval for t and a t plus c is the number of happens is equals to n, which is gives us the Poisson parameter is lambda c, because the interval length is c, and the former length is t, its former length is tau. So we just replace the tau with a c here as a probability mass function with e to the power of minus lambda c times lambda c to the power of n over n factorial, and n is from 1, 2, 3 to infinity. Where c is an increment time. So this time the expected value of a yt here, as we can write it to extract the c from the expected value, and using the linear property of expected value, we can write on some individual ones, and the lambda t cancel out, so the final consequence is yield with a lambda. That is a no relationship with a t, independent with t from t. All right. And the other correlation here, we could also expand it as the same tricky way mapping here, and we got we got the same ideas of a T1 plus C is just different, depends on different and the sequence of a T1 plus C and T2, um, which gives us there is no relationship or as independent from the starting time. It's also only the matter of the interval length. So this pretty much defines a Whiteson stationary process that is a Poisson increment. And um, I think this is represented average numbers of arrival during the time in the interval T1 and T2. Um, it's like um, you got a time, you got arrival numbers, and divided by time, and that is in this interval how many times the event happens in this average interval, like that. And the third question asks about the normal process. Normal process is nothing but given a sequence of a normal distribution and their joint normal. So the joint normal, right? So the expected value is equals to the eta t, and if xt is in white sense stationary, then the normal process is strict sense stationary, which is fair. That is pretty much about question one. Thank you.